Hello, my name is Joshua Sells. This is week 5 assignment for data structures and algorithms. So this assignment we were supposed to implement an AVL tree and we were supposed to kind of replicate a process manager. So executing processes based on priority. So I'm going to go through all these files real quick. I'm going to go over the code for my main application and I'm going to run it and show you what it actually spits out. So first of all, we have our tree interface. This is what I got from the textbook. It's just a base interface for tree data structures. Okay, our binary search tree that implements the tree interface. Okay, we have a tree node that's actually inner class. Anyways, this is also a snippet I got from the textbook, but I have created these methods and added to this class and modified it as I needed to for it to function correctly in my main application. Okay, so this extends, like I said, it implements the tree interface. Now we have our AVL tree, and that extends our binary search tree. What an AVL tree is, it's a binary search tree that is self-balancing. So every time it does an operation, it rebalances itself so that it maintains a log n algorithmic time for searching, inserting, getting elements, stuff like that. Here's a custom class called process info. This is what's going to be held in each node in my AVL tree. It's just a class for processes. So we have a name, ID, priority, runtime. This priority is what my compare to method is based off of in this class. I'm overriding the compare to method and evaluating the process info's priority. Okay. Here we have process list master.txt. So this is just a text file of processes, right? And so it's giving details like this third column is priority. So based on this number, the tree is going to be created, and it's going to traverse through it based on priority. So here's my main application. I create an AVL tree. I load all the processes into it. I print it out a few times in different ways. And then I go through it and I execute a process. So if it hasn't started, the process hasn't started, I'm going to start it here. And then I'm going to try and execute it. Okay? And then I'm going to create an array list to just keep track of the processes that have finished. So if the process is done, then I'm going to add it to the array list and I'm going to remove it from the tree. And so this is all going to run while the AVL tree still has nodes in it. Once it's completely done, meaning the processes have been ran, the AVL tree is going to be empty and our array list is going to be fully populated. All right, and then we're going to just print out the details. So I'm also in my processinfo.java in the execute process method, I use a thread.sleep here. Now normally this would be 1,000 milliseconds, but that's what the instructions wanted. However, if I were to do that, it would take a very long time to run the whole program, so I'm just chopping off 0 for time's sake. So now I'm going to run the main class, and we're going to see it moving. So I'll get back to that in a little bit, but you see here, it's going through the processes and executing them based on priority. So while we wait to that to finish, I'll explain this. So first, we're adding all the processes. We're traversing it. And then this is traversing it in order as well, but with a function argument. So I actually created I created a way for you to traverse through the tree, giving a function as an argument. So here the argument is just print out the toString method, but later on, I'm giving it the argument of the logic to actually execute processes. So let's see here. It finally finished. It listed out all the processes. that were completed, and then here's the result. So completion time 9 seconds, 8, 24, 25. This would be a lot longer, but because remember I chopped off that 0 for thread.sleep just to make the program go faster. So there it is, AVL trees.